Unit 4, Lesson 2, Polygon Angle Sum Theorems. Definition of a polygon is twofold. It needs to have at least 3 straight edges and be a closed plane figure. The idea of straight edges is they're just that, they're straight, they're not curved. And closed meaning that everything has to meet. So that would not be a polygon because it's open. A circle is not a polygon because it has curved edges. Naming a polygon. Listing its vertices consecutively in a clockwise or counterclockwise direction. Pick any vertex, it doesn't have to be the first letter in the alphabet, and list them in either clockwise or pick any other letter and list them in counterclockwise. So I could call it E, D, C, B, A. You don't need anything in front of the first letter. When we get a triangle, we use the little triangle symbol. When we have an angle, we use the little angle symbol. You don't need anything here that when they're squished together closely and we see the closed figure, we know that you're listing the vertices of a polygon. Naming the sides. Sides are line segments. So we could have side length AB, BC, segment CD, DE, and AE. Angles, angle A, angle B, angle C, angle D, angle E. Since this is a pentagon, it has 5 sides, it has 5 angles. The vertices are the points. So no angle symbols needed here. We're just talking about the physical vertex where the 2 sides come together, so that point. Next slide. This slide lists all the names for the polygons. You are responsible to know these. Triangle has 3 sides, quadrilateral 4, pentagon, hexagon. There is one in here missing. 7 is a heptagon. 9, 10, 12. An n-gon stands for any number of unknown sides. So if you wanted to represent something that had 20 sides, it may have a name, but it's not necessarily that we know it, so we would call it a 20-gon. You could have something with 15 sides, so it would be a 15-gon. Recognizing that they all have the same suffix, that they're all polygons. I guess triangle and quadrilateral don't, so we keep the n-gon. Equal angular has equal angles. And they're all equal. So a good example is a rectangle. 4 90-degree angles. Equilateral is talking about having equal sides. And again, all the sides being equal. So a good example of that is a rhombus, where all 4 sides are congruent. And a regular polygon is that it's really taking everything up above. So it has equal angles, and it also has equal sides. An example of a 4-sided figure that is a regular shape is a square, because we know it has all 4 sides and all 4 angles congruent. In regards to a triangle, we have an equilateral, equal angular, regular triangle. And most of the times when we draw pentagons, hexagons, octagons, think of a stop sign, they are regular, that they have all sides the same and all angles the same. This chart is here so that we can find the pattern for the polygon angle sum theorem. What this does is it splits each polygon into a particular number of triangles. We know that since a triangle adds up to 180 degrees, that if we can determine how many triangles are in a shape, we can find the number of degrees inside the entire shape. So pick any vertex of all of these. So we'll start with the 4-sided figure and draw a diagonal across to the other vertex. There are now 2 triangles formed. So we know that 2 triangles, each at 180, is going to give you 360 degrees. I'm going to do the same thing through all of them. Pick any vertex you want to and go across the shape. So in this particular, I can go across 2 different ways, and I have 1, 2, 3 triangles formed. So 3 triangles add up to 540 degrees. I'm going to keep doing this down the rest of the table, and you should hopefully see a pattern. A 6-sided figure, I'm going to start in a corner and go across, across, across. If I were to go here, it's not referred to as a diagonal because it's just the side. So that means I have 1, 2, 3, 4 triangles formed. 4 times 180 gives us 720. This next one has 1, 2, 3, 4, 5, 6, 7 sides. Follow the pattern. Can you guess how many triangles there'll be? Each time it's been 2 less. So if there's 7 sides, you'll end up with 5 triangles. So let's try it. 1, 2, 3, 4 diagonals. 1, 2, 3, 4, 5 triangles. So 5 times 180 ends up giving us 900. So a 7-sided figure has a total of 900 degrees on the inside. And lastly, this is an octagon. Should end up with 6 triangles. Let's try it. One, 2, 3, 4, 5, 6. So because it can be split into 6 triangles, each triangle adds up to 180. You end up with a total of 1,080. So patterning. Number of sides minus 2 is how you get the number that you're multiplying by 180. And that is the theorem. The sum of the measures of the angles of an n-gon is n minus 2 times 180. Reason why they use n is because it's applicable to any polygon. So when there were 5 sides, we did 5 minus 2 times 180, and it gave us the total number of sides. If you were to have a 20-gon, 20 minus 2 is 18 times 180, and that would give you the total number of degrees on the inside. So a couple problems to try. Find the sum of the measures of the angles of a 15-gon. Go ahead, try that one on your own. We'll check it in class. Find the value of angle y. Angle y is down here and we don't know what it is. Recognizing that it has 1, 2, 3, 4, 5 sides, that it's a pentagon. The formula tells me that if I take the number of sides minus 2 times 180, it ends up giving me how much all of them equal to. So if we take 135 plus the 90 plus 90 plus the other 90 plus we don't know, it should all add up to 540. So 1, 2, 3, 4, 5 angles add up to 540. Go ahead and add them up and then subtract them to figure out the measure of angle y. Exterior angle is an angle formed by a side and an extension of an adjacent side. The extension can go clockwise or counterclockwise. Drawing the exterior angles. Pick a side and extend it, and continue extending every side. There will be the same number of exterior angles as there are the same number of interior angles. And likewise, the same number of sides is the same number of angles. There were 1, 2, 3, 4, 5, 6, 7, 8 sides. So there are 1, 2, 3, 4, 5, 6, 7, 8 interior angles. And there are 1, 2, 3, 4, 5, 6, 7, 8 exterior angles. Here's an animation I found that shows the exterior angles. The exterior angles follow the car, go on the outside, there's one of them, the second, the third, the fourth, and the fifth. Exterior angles, the exterior angle theorem says that all of them add up to 180, and it's because you're going around the outside. So the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. The example that was given is for a pentagon, meaning that it has 5. But if we were to have an octagon, then it would go all the way up to 8. So it's not necessarily this picture. If it's a pentagon, then it would be this picture, but if an octagon, it would have 8 sides. One other thing, and it is on the website, this Math Open Reference applet, and I've used this in class. What it allows you to do is to play around with the number of sides and to see all the angles on the outside, and you can see them clockwise, counterclockwise, both if you want to, and it allows you to make it regular. So there's a regular 7-sided figure, and there are its angles. If you notice, all the angles are the same, and it's because all the interior angles are the same, and an exterior angle is just creating a linear pair. So if you know what this is, you're creating 180 degrees. So if these are all the same, then each extension will also be the same. So you can play around with those 2 animations. They are on the website. A couple more. It says find the measure of an interior angle of a regular decagon. It just wants one interior angle, an interior angle. It doesn't say the sum of them. Well, the decagon has 10 sides. I need to determine how many there are total, and then we can go back and we can find how many each one of them, each angle is. So 10 minus 2 times 180, so that gives me 8 times 180. So it looks like, grab a calculator. It adds up to 1,440 degrees total. That's all of them on the inside, but I don't want all of them, I want just one. There's 10 angles, they each measure the same, so that amount divided by 10 gives me 144 per angle, and that's an interior angle. Find the measures of the interior angle of a regular hexagon. That one is for you to try on your own. Letter C, find the measure of an exterior angle of a regular pentagon. Exterior, on the outside. So we have a pentagon, and if you think about extending and traveling all the way around like that car animation did, all the way around is 360 degrees. But because it's regular, each one of these angles is exactly the same. So 360 divided by 5 ends up being 72. And if you go back to the open animation, open math reference, 5 sides, they're all equal. The exterior angles do add up to 360. Go ahead and try letter D. And that concludes lesson 4, lesson 2 from unit 4.